This is Unit 4, Video 5. Here we will talk about how to write ionic compounds using something called polyatomic ions. Now we had written ionic compounds before in the previous unit, so we did something like this. If we had, for example, sodium, and we had to write a compound between sodium and oxygen, what we did is we looked at the periodic table for the charges of sodium and oxygen. Remember, the periodic table has common charges for these groups. So if you're in group 1, which sodium is in group 1, you have a +1 charge. So this whole group has a +1 charge. If you are in group 16, where oxygen sits, you have a -2 charge. And we got that by asking how many electrons does the element gain or lose to become like a noble gas. These are your noble gases, noble. All right, so we said sodium had a +1 charge, oxygen had a -2 charge. Now, when we wrote the compound, we asked ourselves how many sodiums do we need for every oxygen to make them balance out? And we found out that we need 2 sodiums for every 1 oxygen, and our formula ended up being Na2O. This was our ionic compound. So we did this with regular ions. We actually did this with what are called monatomic ions. Monatomic means you only have 1 atom in the ion. Now we're going to do the same thing with polyatomic ions. Polyatomic ions have more than 1 atom in the ion. So for example, this here, you have 2 elements combined together and they form a group with a +1 charge instead of just a sodium. Or you have, for example, a carbon with a bunch of oxygen that combine together for a -2 charge. So this whole group now has a -2 charge. Really, it's the same thing as before, but now we have groups that have these charges. These are actually common in chemistry. So here is, we're going to show you a bunch of them. So here is a list of 6 of the most common polyatomic ions. Let's introduce them to you so you are aware of their existence, and we'll do some problems with them. So hydroxide is one. Hydroxide is written as OH. This is an oxygen with a hydrogen, and it has a -1 charge. Anytime we don't show a number on the charge, we assume it's a -1. All right. Nitrate is NO3 with a -1. Sulfate is an SO4 with a -2 charge. Carbonate is an CO3 with a -2 charge. Now you'll notice that a bunch of them end with this ending 8. Most of them do, not all of them, but a lot of them do, and that actually refers to the fact that you have a bunch of oxygens with that sulfur. Oxygen is the most common polyatomic atom that shows up in these. Oxygen. It doesn't show up in this last one, but it shows up everywhere else. And oftentimes they'll end in 8s. Okay, so phosphate is PO4 with a -3. And then we have a strange one called ammonium. This is really the only positive polyatomic ion. It's also a +1. Notice the rest of these are negative. There's really just a few positive polyatomic ions. Most of them are going to be negative. Okay, so how do we do this? We have 3 example problems: sodium carbonate, calcium nitrate, ammonium hydroxide. Let's do the sodium carbonate first. So we'll take sodium from the periodic table. Again, if you look, sodium has a +1 charge on the periodic table. And now we're going to team them up with carbonate. The carbonate now is a polyatomic ion. And it's this guy here, CO3 with -2. So we'll put him next to CO3 -2. And the logic is exactly the same as before. How many sodiums do I need to balance each carbonate? And so each carbonate is a -2 charge. This whole thing is a -2 charge. So I would require 1 sodium to balance them out. Sorry, I require 2 sodiums, 1 more. So 2 total, sorry. 1 more sodium to balance them out, so 2 total. So when we write the compound, we'll write it as Na2CO3, like this. Not bad. Let's try calcium nitrate. Here, let me erase these and we'll write calcium nitrate up here as well. So calcium from the periodic table, if you take a look, it is in group 2, which means it'll have a +2 charge. Nitrate here, there's nitrate. It's NO3 with a -1 charge. So let's write that. NO3 with a -1 charge. So it looks like we would need 2 nitrates for every calcium, because calcium is a +2 charge. We need a -2 on the other side to balance it out. So 1 more nitrate will be needed. So there's going to be 1 of these and 2 of these. So we'll write it as calcium, 1 calcium, and nitrate will need 2 of those. Now, if you just write a 2 at the end, it looks like you have 32 oxygens, which is a lot of oxygens. And we don't want to say that. We want to say we have 2 nitrates. So we end up having to put parentheses around this whole thing with the 2 on the end. And that's where the parentheses come in. All right. So this is calcium nitrate. Last one, ammonium hydroxide. Let's try to write that. And this one actually contains 2 polyatomic ions in it. So ammonium is given to us here as NH4 plus 1. So that's going to be our cation portion. And then hydroxide is given to us as OH minus 1. That's our anion portion. Notice they're both plus 1 and minus 1, which means they're balanced out. You just need one of each. When you write the compound, you don't show charges. You're just going to write NH4OH, just like that, ammonium hydroxide. So not too much more difficult, really the same thing as we've done before, except now you have to keep these as a group. This whole thing will be the plus 1 charge. So you keep it as a group. You don't split them up, is the idea. There are more polyatomic ions. So here is the next slide, has a bunch of polyatomic ions that are less common, but still less common in the public sense. They're pretty common in chemistry. So some of them you notice are ammonium still in here, but something like cyanide, here's one that's not on that page. Something like chlorate, here's chlorate, that's not on that page. Permanganate, dichromate, Cr2O7 minus 2. So you'll see a lot more. There's actually dozens and dozens of these polyatomic ions that exist in chemistry. We just usually deal with the most common ones. All right, so hopefully that idea makes sense. The second idea in this video is naming, this is going to be the next slide, naming covalent compounds. Now remember, covalent compounds are different from ionic in that they are made of nonmetals. So for example, this is a covalent compound, N2O. And N2O, this is called nitrous oxide, and it's not based on charges. So you don't base it on the charge of nitrogen and the charge of oxygen because they're not ionic, they're covalent. So what we'll have to do is we'll have to name these by using prefixes, and prefixes to tell you how many atoms there are. And this is actually simpler than ionic compounds, even though it may sound more complex at the beginning. You'll see it's quite a bit simpler. So all you need is a list of prefixes, and these are the common prefixes that we will be using. So for 1, we'll use the prefix mono. For 2, we'll use di. For 3, tri. For 4, tetra. For 5, penta. 6, hexa. 7, hepta. Octa, nona, and deca. These are actually common prefixes that are used in common English words, like an octopus, right? Has 8 legs. Pentagon. A pentagon is a 5-sided figure, or it's a government building south of Washington D.C. Still, the building has 5 sides, right? Pentagon still has 5 sides. So you see that these are commonly used, and you'll see these are pretty simple. So carbon dioxide, probably the most famous compound besides water that is covalent. So we have carbon and dioxide, so 2 oxygens and 1 carbon. Notice we don't use mono for the first one because we assume there's 1. We do this a lot in chemistry. We ignore the 1 because we assume there's only 1. So carbon dioxide, 2 oxygens. Simple as that. Dinitrogen pentoxide. All right, di means we have 2 nitrogens, and then pent means we have 5 oxygens. So 2 nitrogens, 5 oxygens, N2O5. Pretty simple. Just make sure you don't mix these up. Make sure you don't write N5O2. Make sure you don't do it this way. The di represents nitrogen. The pent represents oxygen. That's the idea. And the last one is sulfur hexafluoride. So sulfur, again, there's only 1 of them because it doesn't say the prefix, so we assume there's 1. So we'll put 1 sulfur. And then hex, you may have heard of hex nuts. Like nuts you can put on hex bolts, hex nuts that you can use. They have 6 sides. That's why they're called hex. And so we have 6 of them. So sulfur hexafluoride. So fluorides, we have 6 fluorines like that, SF6. So pretty simple. Incidentally, whenever they use these, there is another, you read about, hopefully, carbon monoxide. Carbon monoxide. The second element does get the prefix mono. We don't use mono for the first element. So here we don't say monocarbon monoxide. You don't use the mono for the first one, but you do use it for the second one. It's kind of you don't say carbon oxide, you say carbon monoxide. So it's a little detail. Mono is not used, I said, but you don't use it for the first one. You would use it for the second one. So something like this, for example, N2O would be dinitrogen monoxide. Okay, so that really completes for us this video. Hopefully it makes sense. We'll practice a bunch of these together in class.